Welcome back to Calculus Conundrums for the derivative. And in this video, we're going to talk about the quotient rule. The quotient rule is for finding the derivative of a quotient of two functions. So if you have f of x divided by g of x, and you want to find the derivative of that quotient, then you take the function g of x and multiply it by the derivative of f of x. Then you subtract the function f of x and multiply it by the derivative of g of x. So the numerator kind of looks a little bit like the product rule, but there's two important differences here. This is a minus, so not a plus, and it's very important which of these terms you write first. You must write the g of x times f prime of x first, because if you get it backwards, the answer will be wrong. So g of x times f prime of x minus f of x times g prime of x, and then the denominator is whatever the g of x function is squared. Now, I like the shorthand notation where you say u is f of x and v is g of x, and then you say the derivative of u divided by v is just v times u prime minus u times v prime divided by v squared. Okay, so that's the formula that we use. Now let's start you out with a simple example here. So in this example, I have in the numerator of my function is 1 minus 3x, so that would be my u. And then in the denominator I have 2x minus 5, that would be my v. So now if I do v, which is the denominator first, so I have 2x minus 5, and then if I multiply by the derivative of u, and here I'm just going to show you that we're going to multiply by the derivative of u, so we have the derivative with respect to x of 1 minus 3x, and then minus the u function, which is the numerator, times the derivative of the v function, the derivative of the denominator, and then on the bottom you have v squared. Now this right here is not part of the expression. This is just to show you that there is the v squared. So I went ahead and just wrote that there so you could see that that's the v squared. Now again, you could skip this step and just do these derivatives in your head. So let's go ahead and calculate these derivatives. The derivative of 1 minus 3x with respect to x is minus 3, so I'll write that there beside the 2x minus 5. And then the derivative of 2x minus 5 is just 2, so I'll write that beside 1 minus 3x. Okay, and then on the bottom I still have that quantity squared. Now I need to do some algebra here, so I'm going to have 2x minus 5 times minus 3. And when I multiply that out, I get minus 6x plus 15. And then here, when I multiply 1 minus 3x times 2, I get 2 minus 6x. But remember, I have a negative in front of it. So I have, let's see if we can do this in our head. So we're going to have minus 2 and plus 6x. So let's think about what we would have. Since I would have a minus 6x here and a plus 6x here, these would cancel. And then I would have 15 minus 2, which gives me 13. So my numerator is just 13. And then, of course, don't forget your denominator, the 2x minus 5 quantity squared. And that is a simple application of the quotient rule for finding a derivative. Okay? Now, if you are in a business calculus class or in a class that does not have to worry about trig functions, you can just fast forward through this example to the next example. But if you're a Calculus 1 student, you need to go ahead and look at this example because we're going to incorporate a trig function into this problem. Now on this example, I'm going to do the derivatives in my head. Okay. Now remember, let me go ahead. I'll write this out for you so you know what the u and so the u here would be the numerator, sine x, and the v would be the denominator, x squared. So using the quotient rule, I take the denominator, which is x squared, or v, and multiply it by the derivative of the numerator, so the derivative of u. So this is v, which is x squared, and then u prime, the derivative of sine x would be cosine x. And then I have minus, and then I do the u, which is sine x, times the derivative of v, and the derivative of v would be 2x. And then all over the v squared. So since v is x squared, I have to square it. So I'm going to get x to the fourth eventually. You could go ahead and write it here, but I didn't write it till I got down a couple more steps. Now, clean this up a little bit. You get x squared cosine x here, and then let's put the 2x in front of the sine x, and you get minus 2x sine x. And actually, you could go ahead and make that x to the fourth there if you wanted to. All right, but then one of the things that we can do here is we can actually simplify this a little bit. Notice that in the numerator I have a common factor of x here and here. So if I factor that x out, that'll leave me with x cosine x minus 2 sine x, and then I'll have an x here and an x to the fourth in the denominator. And you should know that you can actually simplify that, because x over x to the fourth is the same as 1 over x cubed. So we can write that, cancel the x into the x fourth, and get x cubed in the denominator. And so we get x cosine x minus 2 sine x all over x cubed. And so that's the derivative. That's the derivative of sine x over x squared using the quotient rule. Okay, so I'm going to go ahead and use the quotient rule here to find the derivative of this one. This is the cube root of x divided by x squared plus 1. So first thing I'm going to do is rewrite this as x to the 1/3. So I have x to the 1/3 over x squared plus 1. So u would be the numerator, x to the 1/3, and v would be the denominator, x squared plus 1. Now, when I calculate the derivative using the quotient rule, I write v times the derivative of the u, and then minus u times the derivative of v, and then all over v squared. Again, this v squared is not really there. It's just showing you that the v squared goes there. Okay, now, so I bring down the x squared plus 1, and then I calculate the derivative of x to the 1/3 using the simple power rule. So I get 1/3 x to the negative 2/3. And then I bring down the x to the 1/3, so I have minus x to the 1/3. And then I calculate the derivative of x squared plus 1, which is 2x. And then on the denominator, I have x squared plus 1 quantity squared. Now, to simplify this, you can actually factor 1/3 and an x to the negative 2/3 out of each of these terms. So what I'm going to do is I'm going to factor that out of this term, and then I'm going to also factor it out of this term. Okay, so if you factor it out of this term, that's the easy part. You're just taking this 1/3 x to the negative 2/3 and putting it on the outside, and you're left with here x squared plus 1. So this is what you have left when you factor there. Now the hard part, I guess, is when you factor 1/3 x to the negative 2/3 out of here. Well, what you have to remember is when you factor 1/3 out of something, that's the same as multiplying it by 2. So I'm sorry, by 3. When you factor 1/3 out of something, that's the same as multiplying it by 3. So that's where the 3 came from. And then if you factor x to the negative 2/3 out, that would be the same as dividing this by x to the negative 2/3. And if you divide x to the 1/3 by x to the negative 2/3, that's the same as multiplying it by x to the 2/3. And then if you take x to the 1/3 times x to the 2/3, you just get x. So in short, when you factor 1/3 x to the negative 2/3 out of here, you'll get 3x times 2x, and you still have the minus there. Now, this is x squared. This is minus 6x squared, so that would give us minus 5x squared, and then we have the 1. So the numerator would be 1 minus 5x squared. Now the x to the negative 2/3, I can move it to the denominator and change it to x to the positive 2/3, and of course the 3 would stay in the denominator. And also the x squared plus 1 quantity squared would stay in the denominator. So this was pretty straightforward, except for probably when I factored 1/3 x to the negative 2/3 out. But you can notice that by factoring that out, I made the function look a lot nicer than it would have had I left it in the form that I had up here. So that simplified it. Now, what's important about this is now if I needed to, I could find the zeros of this derivative if I needed to by setting it equal to 0. I'm going to end this on one that utilizes multiple rules. So on this problem, the first thing I want you to realize, think of this as a quotient, where this is your that's your u, and your v would be the part on the bottom. So that would be your v. Okay, so now you would have, let's see if I can straighten that up. There we go, a little better. All right, so now we would take, using the quotient rule, so let's apply the quotient rule. So we take the v, which is 3t squared minus 2, and we multiply by the derivative of u, so that would be the derivative of the numerator. So there I'm just showing that. So I'm going to multiply by the derivative of this. And then minus the numerator, 5t minus 1 times 3 minus 2t, times the derivative of the numerator, 3t squared minus 2. And then remember, divided by the denominator squared. Okay, so now what makes this a multiple rule problem is to calculate the derivative of this product. I have to do the product rule right here. So let's take a look and do the product rule. So on the product rule, I can just take this function right here. I can take this function, which is 5t minus 1, right there it is, and then multiply it by the derivative of this function, which is minus 2t. And then plus the second function, which is the 3 minus 2t, and you can see I've got that right there, okay, and then times the derivative of 5t minus 1, which would be 5. Okay, so that's how I did that. Now the second portion of the quotient rule wasn't too difficult because the derivative of 3t squared minus 2 is pretty easy. It's just 6t. Alright, so that's where we're at now. Now the rest of this is just algebra. So I don't want to spend a lot of time belaboring this, but let me just tell you this. If you distribute the negative 2 here and distribute the 5 here, all of this becomes minus 10t plus 2 plus 15 minus 10t, which is actually minus 20t plus 17. And then if you distribute the 6t through here, you foil this, and then multiply everything by 6t, you'll get minus 60t cubed plus 102t squared minus 18t. But we still have a minus here, so distribute the minus through, and you get plus 60t cubed minus 102t squared plus 18t. And remember, it's all divided by 3t squared minus 2 quantity squared. And then lastly, go ahead and foil these two, and then when you foil these two and then combine them with these terms here, you should get the final answer. So you might have to do some of that work on scratch paper, but this is a calculus course, so I don't focus a whole lot on the algebra, but I did do a few steps for you. So your final answer is negative 51t squared plus 58t minus 34 all over 3t squared minus 2 quantity squared. And you can see here I'm telling you it is important that you learn to simplify as far as possible in order to find the zeros of a derivative. And you see that later when you get to the applications of a derivative. Okay, so that's all I have now. So in the next step I'm going to talk about the chain rule, which introduces a rule called the general power rule. You might remember we had the simple power rule earlier, but we're going to move on to the general power rule in the next video.